Hi, this is D-CodeWeaver, an interactive design tool developed at Computational Design Lab, Simon Fraser University. It combines parametric modeling with real-time building code analysis for modular timber housing projects. D-CodeWeaver helps designers connect creative modeling with data-driven code logic, which enables faster, smarter, and compliant modular timber design. We start by setting the building parameters and constraints, things like floor area ratio, site coverage, floor height, efficiency, and maximum building height. The system checks that the inputs make sense and then calculates the maximum allowable floor area and site coverage. This number will guide all the next design steps. In the second section, we can specify whether the building is sprinklered or not, so that we can evaluate the facade openings for compliance. When I enable the facade analysis mode, the system calculates the maximum allowable window to wall ratio for each side of the building in accordance with the fire code. Designers can use this as a benchmark during the design process. In the third section, we define the minimum required distances between the building and adjacent buildings. The primary and lateral values control the required setbacks, and by applying them, we can verify compliance with building to building spacing regulations. Now, I can start setting the site by defining the site boundary. I can either draw a closed curve or select an existing curve from the Rhino model. And here, I define the easement areas, places where building is not allowed. I can draw them directly on the site or select them, as you see, and system automatically subtracts them from the total site area. In this box, I assign setback distances to each edge of the site. The system offsets the boundary and shows the dashed lines representing the new buildable zone. Here, I can define the road networks. I can either select them on the site, as you see, or draw them directly on the model, and then set the road width one by one. With all the base information ready, I can now generate the modular building blocks. I start by drawing a line that defines the main corridor direction. The system uses that line to create double-loaded timber modules along it, and it automatically trims anything outside the buildable zone. When I generated all the building blocks and the process is complete, the vertical service cores, including elevator shafts and staircase blocks, will be automatically generated within the building block. Each building block can have its own number of floors. I simply type the value for each building and the system updates their height automatically. If I exceed the allowed limit, it adjusts it to stay code compliant. The floor count and total floor area updates right away. Here I can adjust the staircase orientation. As shown in the model, the staircases are currently parallel to the corridor. By unchecking these checkboxes, they become perpendicular to the corridor on a building by building basis. We can also flip their location to be on the opposite side of the corridor. In the Analysis tab, the system allows us to perform sunlight and shadow analysis. By activating this feature, we can evaluate the impact of adjacent buildings on one another in terms of sunlight access. This helps designers to make informed decisions and adjust the building locations based on the shadow analysis results. The next section allows us to distribute different residential unit types across all buildings using 4 different distribution logics, including balanced, uniform, top-heavy, and random. We have 5 unit types, and here we can set target percentages and see the actual percentages, count, and also extra base or leftovers. Let's distribute the units now. And as you see here, I can adjust the target percentages and see how the system updates the distribution. I can also change the distribution logics according to the design purpose. As you see, the interface generates a bar chart showing the target and actual percentages on the Rhino viewport. And finally, I can explore the performance metrics, including FAR, GFA, building coverage, and efficiency here as a pie chart. And in the last section, I can choose whether to view the entire site, all buildings, or per building information. The system displays the charts for unit mix, efficiency, and gross floor area and overlays them directly on the 3D model. Everything updates live as I make change. Thanks for watching this video.